Hello my dear students, and today I am going to tell you some numericals on transistor circuits. Before that, we should know some formulas which are very essential for the problem solving. And in transistor circuit already it is known to you that the emitter current is equal to base current plus collector current. Emitter current is equal to base current plus collector current. Okay, so this is the case of common base transistor also, and the value of alpha already I have told you in my first video. Alpha is equal to IC by IE. IC by I, change in collector current by change in emitter current, or simply you can say IC by IE. Okay, and if RL is the load resistance and VO is the voltage drop across the load, then IC across the collector load, so then IC will be equal to V0 by RL. Clear? And another important formula, IC in a common base, IC is equal to alpha into IE plus ICBO. And what is the meaning of ICBO? IE is the emitter current, this is the collector current, ICBO. Common base current with open emitter circuit. Common base current. Common base current means there is no current in the emitter circuit. That means emitter circuit is open. If a circuit is open, so there will be no current through it. So this is called collector base current with open emitter circuit, ICBO. Clear? So now we will do some problems depending upon these formulas. Okay, so let us start. See here, determine the value of base current in a common base transistor connection if emitter current is equal to 3 milliampere and collector current is equal to 1 milliampere. Emitter current is given, collector current is given, and you have to find out base current. That means you have to find out IB. And we know IE, already I have told you, IE is equal to IB plus IC. That means IB is equal to how much? IB is equal to IE minus IC. Okay, so IE is equal to how much? 3 milliampere minus IC is equal to 1 milliampere. So it is equal to 2 milliampere. So first of all, you have to remember all these formulas. Then only you can do the problems very easily. Okay, so let us come to the second problem. See the second problem. In a common base configuration of a transistor, the emitter current is 2 milliampere and the current amplification factor means alpha. Alpha is equal to 0.98 and you have to find out base current. That means, see here, what are the given conditions? So given IE is equal to 2 milliampere and alpha is equal to 0.98. Clear? And we know alpha is equal to IC, change in collector current to the change in emitter current. That means IC by IE. Clear? So by cross multiplying, IC is equal to how much? Alpha into IE. Clear? So alpha is equal to 0.98 into IE is equal to 2 milliampere. So it will be equal to 1.96 milliampere. Clear? So now IC is known, IE is known, so you can find out IB. That means again we know IE is equal to IB plus IC. So from this we have IB is equal to IE minus IC. Clear? And IE is equal to 2 milliampere minus IC is equal to 1.96, which is equal to 0.04 milliampere. Okay. So you should remember the formula for alpha, and you should remember the formula IE is equal to IB plus IC. Then only you can do the problems very easily. Okay. So let us move to this next problem. See here, in a common base transistor circuit, IC is equal to 0.9 milliampere, IB is equal to 0.04 milliampere, and you have to find out the current amplification factor. That means you have to find out alpha. Okay. So how to find out alpha? First of all, we know emitter current is equal to base current plus collector current. Okay, and base current or collector current are known, 0.04 plus 0.9. Okay, so is equal to 0.94 milliampere. Clear? So IE we have got. Now therefore alpha is equal to, the formula for alpha is IC by IE. Clear? IC by IE. Then IC is equal to 0.9 and IE is equal to 0.94, and by dividing you will get 0.957. Clear? So because the formula for alpha is IC by IE, IC is known, so you have to find IE, and IC, IB are given, so you can find out IE. IE is equal to IB plus IC. So after getting the value of IE, you can apply the formula for alpha, then you will get the result. Okay. So let us move. See here, in a common based connection, IE emitter current is equal to 1.5 milliampere. If the emitter circuit is open, that means in this case there will be ICBO, as I have told you. If the emitter circuit is open, that means there will be no current in the emitter circuit. Then the collector current is 40 microampere. If alpha is 0.9, then find the total collector current. Total current means total collector current here. So see here given IE is equal to 1.5 milliampere and alpha is equal to 0.9, and this collector current, that means it is ICBO, that means collector base current when the emitter is open. ICBO is equal to 40 microampere. So you have to find out total collector current. Therefore total collector current is IC is equal to alpha into IE, as I have told you, plus ICBO. Clear? Alpha is known, IE is known, ICBO is known. So put the value of alpha, it will be 0.9, then into IE is 1.5, then plus it will be ICBO. ICBO is 40 microampere, and micro is and you have to convert it to milliampere. So if you convert it to milliampere, then 40 finally into 10 to the power minus 3 milliampere it will become. So it will become 40 into 10 to the minus 3, and now if you calculate this one, you will get 1.39 milliampere. So this is your answer. Okay. So another question, in a common base transistor connection, alpha is equal to 0.92 current amplification factor is 0.92. The voltage drop across the collector load of 2 kilo ohm is 4 volt. That means voltage drop is 4 volt. That means given, see here, what are the given? Let us see. Given alpha is equal to 0.92 and 4 volt, that means V0 is equal to 4 volt voltage drop, and 2 kilo ohm, it is the load resistance RL. Let us write here RL is equal to 2 kilo ohm. It will be equal to 2000 ohm. And first of all, you have to find out IC, because IB is equal to IE plus IC, and alpha is given. From alpha you can find out IE, and here from V0 and RL we can get IC. IC is equal to V0 by RL, because I is equal to V by R, and it is collector current, and it is the collector load, and this is the voltage drop across the collector load. So V0 by RL, V0 is equal to 4 divided by 2000. Okay, so it is equal to 1 by 500. Now alpha is equal to, your alpha is equal to IC by IE. So it implies IE is equal to how much? Tell me. IE is equal to IC by alpha. IC by alpha. So alpha is known, IC is known. So putting the value, you will get 2.173 milliampere. So this is the value of IE. So IE is known. Now IC also known. So now you have to find out IB. So now IE is equal to emitter current is equal to base current plus collector current. So it implies IB is equal to how much? IE minus IC. So IE is equal to 2.173 milliampere, and IC already known to you, 1 by 500. So putting these values, you will get the value IE and IC. You will put these values, you will get IB. So I am not putting these values, you will put the values so that you will get the result. Okay, so please do all these problems and remember the formulas, so that in my next class I will do some more problems on transistor circuit. Okay, so till then, bye bye.